Hey everyone, Praveen this side. I hope you guys are doing great in your life, and if you're not, keep hustling. You will definitely reach the height of greatness. So today we are going to solve the problem Kadane algorithm, which is a medium level problem. And Kadane algorithm is a standard algorithm for finding maximum sum from the subarrays of the given array. So instead of giving the problem title as find the maximum sum of the subarrays, they directly gave it as Kadane algorithm. So the problem description says given an integer array ARR, you need to find and return the maximum sum possible from all the subarrays. So that's what we discussed, right? So the problem description is clear. Now let's see the examples. In example 1, the array is given as 2, 3 minus 8, 7 minus 1, 2, 3, and the output is 11 because the explanation says the subarray 7 minus 1, 2, 3 has the largest sum of 11. So they are considering this subarray because this subarray generates the maximum sum. And similarly, for second example, the array is given as minus 2 and minus 4. Here, the output is 2. And the explanation says the subarray minus 2 has the largest sum minus 2, right? So an individual element can also be considered as subarray or the contiguous elements in the array is also called a subarray. That is, we need to consider the whole subarray without breaking them in pieces. That is the difference between subarrays and subsequence. Subsequence goes like you take one element from here, another from here, where it doesn't follow the property of contiguousness. But that is not case in the subarray. In subarray, we need to consider the whole contiguous array, right? And similarly, in example 3, the array is given as 5, 4, 1, 7, 8, and the output is 25. The explanation says the subarray 5, 4, 1, 7, 8 has the largest sum 25. So basically, the whole subarray is considered as a maximum sum subarray. So we are clear with the topic of subarrays and have understood all the examples. So let's get into observation so that we can solve our problem. Now let's consider this array of 1, minus 2 and 3, and here I have drawn the graph. Now why did I draw this graph? You will understand it. Now in the worst case scenario, what could be the maximum sum of subarray? The whole subarray, right? So we will accumulate one element after the other and plot their points in the graph. Now when we take the single element 1 and plot it in the graph, it will be plotted somewhere here. Then if we add 1 to minus 2, then it becomes 1 minus 2, that is minus 1. So the next point that we are plotting in the graph is at minus 1, right? Here at each plotting point I am taking a unit distance, okay? Now in the minus 1, if we add our next element 3, then the sum becomes 3 minus 1, which is 2. So we'll plot 2 somewhere here, right? Now we will join all the points, that is from 1 to minus 1 and from minus 1 to 2. Okay, so when we consider the whole array as a subarray, what is the maximum sum that we got? The sum is 2, right? But is 2 is the maximum subarray? No, because if we have just considered 3 and plotted a point, then 3 would be somewhere here, right? And the maximum sum would have been 3, right? So 3 individually is the maximum sum subarray of this whole array. So where did we fail for not getting 3? Till 1 we were okay because it was lying on the positive plane of the graph, right? But as soon as we added minus 2, it went from positive plane to negative plane, right? And from this negative plane point, when we added 3, we got the whole length as 2, and length 1 of the whole line was remained in the negative plane, right? That's why we were getting the whole line length as 2, right? That is the maximum sum. But if this point was plotted in this line, then we would have got the whole sum as 3, right? So this length was dragging the whole line to the negative phase. So what do we observe from our observations is that whenever our line gets into negative plane, whenever our sum gets negative, reset it to 0 so that our sum can be as maximum as possible, right? And we can save this extra portion which was going into negative plane, right? So these are the two important points that we should be considering about. That is, keep adding elements to the sum, and once the sum gets negative, reset it to 0. And while calculating this sum could be potential maximum sum, right? So while always calculating the sum, parallelly we'll update our max sum also. And whatever max sum gets generated, we will return it. Now let's keep this observation in mind and solve one example. So this is the array that we are going to try run. For that, I have taken two variables. One is current sum, which is initialized to 0, and the maximum sum, which is initialized to smallest negative number possible, so that we can maximize it as maximum as possible. So let's dry run it. First, we'll come at index 0. At index 0, the element is 2. So we'll add this element to current sum. So the current sum becomes 2. And as I said, while updating the current sum, we need to parallelly update the maximum sum too. So we'll check whether the current sum is greater than maximum sum. Yes. So we'll update maximum sum by 2. Okay. Now at index 1, the element is 3. So we'll add 2 plus 3, which becomes 5. And we'll check whether 5 is greater than 2. Yes. So maximum sum gets updated to 5. Now at index 2, the element is minus 8. So we'll add minus 8 to 5. So 5 minus 8 becomes minus 3. Right. So the current sum becomes minus 3. Let me rub this part. Now we'll check. Is minus 3 greater than 5? No. So we'll not update the max sum. But a main point to be observed is that we got a current sum to be negative. So what did we discuss above? Whenever we get a current sum as negative, reset it to 0. So we'll reset it to 0. Okay. Let me clean this up. So our current sum becomes 0. Now at index 3, the element is 7. So we'll add this 7 to current sum. So the current sum updates to 7. And we'll check whether current sum is greater than maximum sum. Yes. So we'll parallelly update the maximum sum to 7. And we'll check whether 7 is less than 0. No. So we'll go to next index and we'll check what is the element. It is minus 1. So 7 minus 1 will become 6. And 6 is not greater than 7, so we'll not update the maximum sum. At index 5, the element is 2. So we'll add 2 to current sum. So our current sum becomes 8. And we'll check 8 is greater than 7. Yes. So maximum sum updates to 8. And finally at index 6, the element is 3. So we'll add 3 to the current sum. So our sum becomes 11. And 11 is greater than 8, right? So our maximum sum becomes 11. And here our whole array is traversed and the maximum sum that we achieved is 11. So 11 is the maximum sum that we achieved, right? So this is how Kadane's algorithm goes. It is a standard algorithm to find maximum sum from the subarray, right? And if you find any similar problem where we need to find maximum sum from subarray, you can definitely give a try with Kadane's algorithm, right? So we have understood the execution too with this example. Now let's understand the code. So this is the code in C++, although the logic remains same. So the function name is max subarray sum and an array is passed as parameter, right? So first I have taken the size of subarray and I have initialized two variables, max sum and the current sum. Maximum sum initial value will be as minimum as possible so that we can maximize it, and the current sum value is 0. So we are looping from 0 to n minus 1 and accumulating the current element in the current sum. And while accumulating the current sum, we are also updating the max sum by finding the max of max sum and the current sum. But this is the important step that we need to follow, which is if our current sum gets less than 0, then we need to update our current sum to 0, right? So after executing the loop, we'll get our maximum sum updated and we'll return the maximum sum. So the code is very similar to what we have gone through. Now, what will be the time complexity for this approach? Since we are running a single for loop, so the time complexity becomes O of n, where n is size of array. And what will be the space complexity for this? Here we are just using the variables and no any extra data structure. So the space complexity becomes O of 1. So these were the time and space complexities for this algorithm. So I hope you guys like this video. If you guys really did, then please like, share and subscribe to my channel. And if you have any doubt at any point, please comment it down so that I can respond to it as quickly as possible and we can solve that issue. And if you have any feedback on my teaching, please comment it down too so that I can improve on that. So let's meet you guys tomorrow solving any other kind of problem. Till then, stay safe, stay happy and peace.